All right, so we're going to learn how to simplify square roots today. So we know how to simplify square roots of perfect square numbers. We're going to start with that because that's what we know how to do. If I come up and say, what is the square root of 9? You guys know how to do that. What would the answer be?
3.
3. Good job. Why is the answer 3?
Because 3 times 3 is 9.
Because 3 times 3 is 9. So that basically comes from the fact that we're trying to figure out what squared is 9. And the answer that we end up putting in that blank is 3. So JP, we're recording. We just started notes. You need to get that out. All right, so we can use square roots to solve equations. So I just want to throw that in there because that's something that we've done. If I have an equation like x squared equals 100, you probably know in your heads what x has to be. But what I want to emphasize is that the opposite of squaring a number is square rooting. So if I square root both sides of the equation, then I get my answer. So the square root of x squared just becomes x. And then this is actually kind of a trick question. Now that we're in high school, we're going to think about it. What is the square root of 10 just from what you learned in middle school?
I mean, you said 10.
10. But there's actually another number that times itself equals 100.
100.
So 10 times 10 is 100. I want you to think about integers.
20 times 5.
Negative
Nope.
10.
Negative 10. So it could be 10 or negative 10 technically. Either one of those times itself would give you 100. And in high school, we often write that there's a symbol that actually is plus or minus 10. And so instead of writing 10 or negative 10 separately, this is how you would do that answer. So this is just plus or minus 10, which just means positive 10 and negative 10 are a solution. Okay? Now, if it's not a perfect square number, let's say I have x squared equals 32, we can still solve this and come up with an approximate answer. I square root both sides. When I square root the x squared, that just gives me x by itself because we're looking for x. And then over here, if I square 32, there is no integer or whole number that times itself makes 32. The best that we could do with what you know so far is type this into your calculator and come up with it's about 5.7. But it actually has a lot of decimals, and this ends up being an irrational number. When you take the square root of a number that's not a perfect square, you get an irrational number that goes on forever and ever without any patterns. And so it's interesting. We have to round it off, and we're left with something that's not exact. So what we're going to do today is talk about how we can simplify square roots without going to the decimals and make sure that everybody comes up with the same answers. And then I'll explain a little bit at the end sort of how this came about, which maybe that's out of order, but that's what I'm going to do. So draw some sort of dividing line, however you want to do that, between here. This is sort of the stuff that we've already done. The stuff you guys did in 8th grade quite a bit, a little bit last year. So we're going to move into the new stuff down here. Now the directions for this a lot of times is just going to say simplify. And that's sort of a general statement, and you're supposed to know what to do with it. Sometimes they will be a little bit more clear, and when they will say write in simplest radical form or something to that effect. So I want you to write those down because there's different ways of stating those directions. I think on today's assignment it actually says to write it in simplest radical form. But in the future, you're going to get a lot of different things all in the same assignment, and it's just going to say simplify, and you're supposed to know what that means. So I'll walk you through how we simplify square roots without going to a decimal. So we're going to start off with example number 1. We're going to look at the one we just did, the square root of 32. So we're going to write down the square root of 32 over here. And this actually starts with using the birthday cake method that we learned yesterday for prime factorization. So you're going to need to skip down a few lines, let's say 7 or 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. That should be good. And we're going to put 32 at the bottom, and we'll build our birthday cake up. So what prime number can you think of that'll go into 32? 2 is the only one we can really think of. So if I take 32 divided by 2, 16. And then I could divide by 2 again and get
Well, can we do 4?
8. You have to use a prime number. 4 is not prime. That's a good question, but we have to use prime numbers each time. So 8, then we can divide by 2 because that's prime. We get 4. And then I have to divide 4 by a prime number. We get 2. And you get 2. And then divide 2 by 2. We get 1. And we're not going to write it today using that. So I'm going to put my candle on the birthday cake like we talked about yesterday. That's how we know we're done. So we get to 1. This would be 2 to the 5th, but that's not really going to help me today. So I'm going to look at this. It's 2 times 2 times 2 times 2 times 2. Okay? So we're going to rewrite 32 in that factored form. So we're going to write a square root, and we're going to write 2 times 2 times 2 times 2 times 2. When we're doing square roots, we want to find things that are squared. So I'm going to take a highlighter, and I'm going to group the 2's in pairs. So these 2 2's I'm going to put together, and these 2 2's go together, and then there's 1 left over. So why am I doing that? Well, this would be 2 squared, and this is 2 squared. If I take the square root of 2 squared, I would just get 2. If I take the square root of 2 squared, I just get 2. So I have 2 times 2, and those are now outside the square root sign. This one is not squared. It doesn't have a partner, so it has to stay inside the radical. The square root sign's called a radical. Okay, so whatever we boxed in here in pairs comes out here. You can multiply those together. So 2 times 2 becomes 4. And then you still have a square root of 2 on the inside. It's kind of like dividing with a remainder, but it's a little different. And the reason why we would do this happens to come from, there's a lot of different ways to write the same number. If I took 4 times the square root of 2, I would get that rounded off to 5.7 number that I got from the square root of 32. If I had 2 times the square root of 8, I would also get 5.7. So we could all have different answers, and they're all the same number, which gets confusing. So what they like to do is have us write it in this reduced radical form so that we all get the same number. And we use this radical form a lot when we do trig, and that's why I'm covering it with you guys today. We won't use a lot of decimals in trig except on the story problems. We'll do a lot of exact form. So this is considered to be an exact answer. So sometimes in the directions it'll say give an exact answer. This is an exact answer that's simplified, where the 5.7 was rounded off. It's not exact. You'd have to figure out how many decimal places to keep, and it just becomes a little bit strange. Okay, so we're going to do another one. We have room for one more probably down here. So if we scooch down, I'm going to come down here and do number 2, and that is the square root of 500, which is a fairly big number, but we can work with it. So down at the bottom of your page, we're going to do the birthday cake method for prime factorization for 500. You could do a factored tree too.
Could we do 5 as the...
So we could start with 5, yeah. So any prime number, you can start with 2 or 5. They're both prime numbers that go in. So I could start with 5. So if I take 500 divided by 5, what do I get? 100. And then we could also divide by 5 again. So I'm just going to stick with 5s until I can't. So 100 divided by 5 would be what?
20.
20. Can I divide by a 5 again?
4.
Yes. So you can divide by 5 again. You get 4. So I can't divide by 5 now. What could I divide by? 2. So 2 is the prime number that goes in. I get 2. and then divide by 2 again. Remember, you keep going until you get the 1, that's the candle on the birthday cake. So if we were writing out just the prime factorization, we'd say 5 cubed times 2 squared. It's not really what we want for today. We want to just put it all under a radical so that we can try to find squares that we can get rid of. So this is 5 times 5 times 5 times 2 times 2. Let me fix that 5. It looks a little funny. And so we're looking for things that we could write in squared form. So we could do these 2 5s together, or any 2 of them, it doesn't matter. So 2 of those would go together, and that would be a 5 squared. And I could do the 2's together, and that would be a 2 squared. So if I square root 5 squared, what would I get?
25.
So I'm square rooting 5 squared. So I'm doing the square root of 5 squared. So the square root and the square would undo each other. They're opposite operations.
5?
So we just get 5. So whatever the number is in your box, we had 5 and 5, it just becomes 1 5. Because basically this is 25 and we're square rooting it to just get 5, and it's outside of the, I don't know, this is strange, but I used to always think of this as sort of a jail, and if you had a buddy, you could bust out.
I'm so confused now. Why do you unsquare root the square root?
Because we're simplifying a square root. So we're coming up with as many square numbers as we can. So maybe what would make sense to you is if I have 5 and 5, that's 25. So what I'm doing is taking the square root of 25 and making it 5. Because that's a number we can square root, right? Does that make more sense?
Yeah.
All right, so over here I have 2 times 2. So what I'm really doing is the square root of 4. So the square root of 4 would be what? 2. So I'm going to put that over here. So I have 5 times 2. Those are the things that sort of busted out. And then this 5 did not have a partner to bust them out of jail. That's just sort of how my brain thinks of this. So that's going to stay underneath the radical. There's still a 5 in there. So then anything that's out here we multiply. So I get 10 times the square root of 5. And that's my final answer. And it's an exact answer. And if everybody does all of this like they should, we will all come up with the same thing. So that's the 5 that didn't get to come out because it didn't have a partner. It wasn't squared. Okay? And you can't take the square root of 5 without getting an irrational number. So what we were doing is basically we were finding square numbers under there by looking for the pairs, thinking of them as squareds. So that's what we're doing. So what we're going to do next on the practice page, I'm going to give you 2 more and let you try it, and then I'll help you if we need to. So on the practice page, for number 1, we're going to do the square root of 90, and for number 2, we're going to do the square root of 45, and I'm going to turn the video off.